Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is 9th class in linear programming chapter. Till now we completed 2 problems in exercise number 12.2. By this time I hope you got clear idea how to do these linear programming problems. Especially in second exercise problems, total 3 types of problems are there. One is diet problem, another one is manufacturing problem, third one is transport problems. In this class, we will do manufacturing related problem. Understanding the question is the key. Spend some time, try to understand the question. After understanding the question, if you can write what is objective function, what are the constraints, then the job is done. Rest of all is very easy only. Before going to start this video, please drop a like for this video and share it with your friends. Let's begin the class. This is question number 3 in exercise number 12.2. You observe this is manufacturing based problem. A factory makes tennis rackets and cricket bats. Okay, there is a factory which makes tennis rackets and cricket bats. Okay, a tennis racket takes 1.5 hours of mission time and 3 hours of craftsman's time in its making. To make a tennis racket, it takes 1.5 hours of mission time and 3 hours of craftsman's time. Okay, and while cricket bat, to make a cricket bat, takes 3 hours of mission time and 1 hour of craftsman's time. Okay. In a day, this is important, in a day, the factory has the availability of not more than 42 hours of mission time. Mission's availability of mission is not more than 42 hours. In a day, mission will be available for 42 hours. Like it may be 2 missions or 3 missions, like that. Many missions are there. So in a day, not more than 42 hours of mission time is available and 24 hours of craftsman's time. Okay. So in this, if you observe one thing, all the data is in terms of hours only. All the data what they given, that is in terms of hours only. So we'll keep this as it is. Okay. Now, in this 2 questions are there. You forget about the second bit. At the end, we will discuss this. Now, first we will do one problem of this. That is first bit. What is the first bit? What number of rackets and bats must be made if the factory is to work at full capacity? That means, what is the maximum productivity? What is the maximum number of rackets we can make when factory works at its full capacity? This is the question. So first thing is, after reading this question, we'll understand what is objective function, what are the constraints. So, right, objective function I am writing by taking this first bit only. Okay, right. Let's write the given data. Number of tennis rackets equal to X. You take number of tennis rackets equal to X and number of cricket bats equal to Y. Now, whatever the data they given in the question, I'll write it in a table form. You observe here in second bit, they mention that the profit of rocket and bat is 20 and 10 respectively. That means they'll make a profit of rupees 20 on tennis racket and they'll make a profit of rupees 10 on cricket bat. This also I'll include in the table, right? So whatever given data is there, we'll write in table form now. You observe here data related to tennis rackets. Number of tennis rackets, we suppose that number of tennis rackets is X, right? And mission time, availability, how much time is required to make one tennis racket? They mentioned that tennis racket takes 1.5 hours of mission time and craftsman's time 3 hours, that they mentioned in the question. Okay, and the profit on tennis racket is rupees 20. So all the data what they given related to tennis racket I written in this table. Now cricket bat. I supposed that number of cricket bats equal to y, and what is the time required, what is the mission time required to make a cricket bat. In the question only they given 3 hours of mission time, okay, and 1 hour of craftsman's time. And what is the profit we will get? 10 rupees profit we will get on cricket bat. Okay, now for the first bit, to do this first bit, I'll identify what is objective function and what are the constraints. First thing, objective function. See here, number of rockets and bats. Number of rockets and bats is the objective function, because when factory works at its full capacity, what is the maximum number of rockets and bats we can make, right? So what is the objective function for the first bit? Number of rockets and bats. For first bit, objective function, number of rockets and bats. As I taken x is number of tennis rackets, y is number of cricket bats, x plus y, this is the objective function. Okay, now I'll write mission time availability. In the question they given that in a day mission is not available for not more than 42 hours. So I'll write objective function of mission availability 1.5 into x plus 3 into y. They mention that mission time, availability of mission time, see availability not more than 42 hours. Not more than 42 hours means less than or equal to 42. Availability of mission time in a day is less than or equal to 42 hours. So here what I'll write, availability of mission time, this is the constraint related to mission time. Okay. Now this mission time constraint is over. Now I'll write craftsman's time constraint. Okay. So what you will get, 3 into x plus 1 into y. Okay. 3x plus 1 into y. 1 into y is nothing but y only. Craftsman time availability is 24 hours. They given in the question only. Look here, 24 hours of craftsman time availability, right? So I'll write this is less than or equal to 24. Okay. Now we have objective function and constraints. And what about x and y? X is number of tennis rackets, y is number of cricket bats. This will be either 0 or more than 0. It never be like half tennis racket or minus 1 tennis racket, minus 2 cricket bats. It won't be like that. So here x and y are non-negative constraints. X is greater than or equal to 0. Y is also greater than or equal to 0. Now we got objective function and constraints. So to solve this problem, we'll follow the steps. What is step 1? By using constraints, we'll identify the feasible region. After identifying the feasible region, step 2 is we'll identify the corner points. After finding corner points, step 3, substituting these corner points in the objective function. Okay. To identify the feasible region, first we'll graph this inequality. To graph this inequality, we need the line 1.5 into x plus 3y equal to 42. To draw this line on the graph sheet, we need 2 points on this line. To find 2 points on this line, we'll draw a table like this, x value, y value. If you put y value 0 in this, then you will get 1.5 into x equal to 42. 1.5 can be written as 3 by 2. 3 by 2 into x equal to 42. So here 3 in this, how many times? 1, 4, 14 times. So what is x? X equal to 28. So when y equal to 0, you will get x equal to 28. So 1 point on this line is 28, 0. Now you put x0 in this equation. You put x0 in this equation. If you put x0 in this equation, you will get 3y equal to 42. Then what is y? Y equal to 14. Right? So 0, 14. Now you know 2 points 28, 0, 0, 14 on this line. So I'll draw this line on the graph sheet. Now you mark the points 28, 0 and 0, 14. You see here, this is somewhere here you will get this is 28, 0 and 0, 14. You join them and draw a line. You observe I drawn a line passing through these 2 points. For this line, 2 sides are there. This side is origin side and this side is non-origin side. As origin side, non-origin side are present for this line, I'll put 0, 0 in this inequality. Put 0, 0 in this. In place of x you write 0, in place of y you write 0. What you will get? 0 less than or equal to 42. Is 0 is less than 42? Yes, 0 is less than 42. So it is true. When you got true, which side you need to shade? You need to shade towards origin side. So you shade towards origin side. You observe here this yellow color shaded part is there. That is solution of this inequality. That means if we take any point in the shaded region, if we substitute that point in this inequality, it satisfies. This yellow color shaded part is the solution of this inequality. Now to find the feasible region, I'll graph this inequality 3x plus y less than or equal to 24. To graph this, we need the line 3x plus y equal to 24. So to draw this line, we need 2 points on this line. For this, I'll consider a table like this. Now you put y equal to 0 in this equation. You will get 3x equal to 24. From that you will get x equal to 8. So one point is 8, 0 on this line. Now you put x equal to 0 in this, then you will get y equal to 24. So you mark the points 8, 0, 0, 24 on the graph sheet. Observe here, this is 8, 0, this is 8, 0 and 0, 24. You draw a line passing through these 2 points. You observe this blue color line. For this blue color line, this side is origin side and this side is non-origin side. As origin side, non-origin side are present for this line, I'll put 0, 0 in this inequality. You put 0, 0 in this inequality. What you will get? You will get 0 less than or equal to 24. Is 0 is less than 24? Yes, 0 is less than 24. As you got true, which side you need to shade? You need to shade origin side of this line. So you shade origin side of this line. You please observe this blue color shaded part. What is this? That is solution of this inequality. That means in this blue color shaded part, if you take any point, substitute that point in this inequality, it satisfies. Okay. If you observe the common region that we will get from these two inequalities. What is the common region we will get from these two inequalities? You observe here, this part is there in yellow color part as well as blue color part. So this is the common region that we will get when we consider these two inequalities. But in the question you see here, x greater than or equal to 0, y greater than or equal to 0 is also there. That means x is positive, y is positive in first quadrant. So if we consider these inequalities also, x greater than or equal to 0, y greater than or equal to 0. What is the common region that we will get that satisfies all the inequalities? What is the feasible region? Feasible region is the common region obtained from satisfying all the constraints. So as our solution must be in first quadrant and it must satisfy these two constraints. You can observe this is the feasible region. In this region, if we take any point, that point satisfies all the constraints. So you identified feasible region. You shade that feasible region. You observe here, this feasible region is bounded feasible region. You know that when the feasible region is bounded feasible region, conditions will be less. We can do the problem very easily. So to solve this linear programming, step 1 is finding the feasible region. We identified feasible region. Step 2 is what? Finding corner points. You see, this is one corner point, second corner point, third corner point. We already know these points. This point is 0, 0 and this corner point is 8, 0 and this point is 0, 24, 0, 14. Now this corner point we need to find. What is this? This corner point is point of intersection of these two lines. Okay. So what I'll do, I'll solve these two lines to get this point. Now I'll solve these two lines to get that corner point. Here little bit of simplification is there. This 1.5 is there, that I can write 3 by 2 into x plus 3y equal to 42. Now I'll multiply this equation, complete equation with 2. Multiply complete equation with 2, then what you will get? You will get that 3x plus 6y equal to 42 into 2, that is 84. Now this equation is nothing but this equation only, right? So I'll solve this equation and this equation. 3x plus 6y equal to 84. While solving, you just subtract. When you subtract, this 3x will get cancelled. Y minus 6y is minus 5y equal to 24 minus is minus 60. Okay, so y equal to what? Minus we will get cancelled, 12. You put y equal to 12 in this equation, then what you will get? You will get 3x plus 12 equal to 24. 3x equal to 24 minus 12, that is 12. X equal to 4. Now you got the point x comma y. What is x? 4. What is y? Y is 12. So the point x comma y is 4 comma 12. Now we got this corner point. This corner point is 4 comma 12. So step 1 is identifying feasible region. Step 2 is finding corner points. What is step 3? Substitute these corner points in the objective function. What are the corner points we got? One is 0, 0 and other corner points are 8, 0, 4, 12 and 0, 14. These are the corner points we got from this graph. Okay. Now I'll substitute these corner points in the objective function x plus y. You put 0, 0 in this, then what you will get? You will get 0 only. You will put 8, 0 in this, z equal to 8. Now you put 4, 12 in this, that is nothing but 4 plus 12, that is 16. Okay. Now you put 0, 14 in this, 0 plus 14, you will get 14. If you observe in this, what is the maximum value? Maximum value is 16. What they are asking, find the number of rackets we can form when the factory works at full capacity. When the factory works at full capacity, total number of rackets and bats we can form is 16. In that also 4 tennis bats, 12 cricket bats they can manufacture. So I'll write here. See, as the feasible region is bounded feasible region, from the corner point table only we can declare where the objective function is maximum and what is its maximum value. So this is the solution for first bit. Z equal to x plus y is maximum at 4, 12 and maximum value, and the maximum value is 16. I hope you are understanding. If you observe the second bit in this, what is the second bit in this question? If the profit on the racket and bat is rupees 20 and 10 respectively, find the maximum profit. See here, maximum profit. Profit is the objective function. We need to maximize the profit. Maximum profit of the factory when it works at full capacity. So for the second bit, what is the objective function? Objective function is 20x plus 10y. 20x plus 10y. Suppose he sells 1 tennis racket, 2 cricket bats. What is the profit he will get? 1 into 20 plus 2 into 10. Correct? So if we want to calculate profit, what is the objective function here? Profit. What is the profit? 20 into x plus 10 into y. This is the objective function for the second bit. So and the conditions are as usual, constraints are as usual. So this graph is similar for second bit also. So now I already drawn this feasible region. We already know corner points. What I'll do, these corner points I'll substitute in the profit function. What is profit function? 20x plus 10y. So for second bit, objective function is 20x plus 10y. Now substitute these corner points in the objective function, then what you will get? 0. And when we substitute this point in this, what you will get? 20 into 8, that is 160. Substitute this in this, 20 into 4 plus 10 into 12, that is 200. Substitute 0, 14 in this, what you will get? You will get 140. As they are asking to maximize the profit, in this maximum value is 200. As the feasible region is bounded feasible region, here only we can declare that maximum value of objective function, where it is maximum and what is its maximum value, we can declare here itself from the corner point table. In case if the feasible region is unbounded feasible region, we will go with one more step that you already learned in first exercise problems. Okay, so as the feasible region is bounded, I'll conclude here only. Z equal to 20x plus 10y, that means profit is maximum and the maximum value is rupees 200. You can observe this corner point table. If you observe this corner point table, here when the factory works at its full capacity, maximum number of rackets and bats that can be formed is 16 and the maximum profit is rupees 200. I hope you are understanding this. So this is solution of this problem. If you like this video, please drop a like and share it with your friends. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye bye.